All right, so this is our flipped lesson about quadratic equations and the greatest common factor. Now, this lesson is just to supplement our idea when we solve quadratic equations. The goal is that we want to find the x-intercepts, the roots, the zeros. But an easier way to do this is by getting it to the simplest number we can. We want to try to make sure all of our numbers and coefficients are as easy as they can be so we can solve it quicker. So we're going to focus on this one part of solving or finding the greatest common factor. Now, when we do that, again, let's go ahead and review. It's sort of the opposite of the distributive property. So remember, in the distributive property, you distribute the one term on the outside of the parenthesis to everything on the inside. I like calling it the wave, because it looks like a wave, you know? Okay. And when you distribute, we multiply. So 8 times y is 8y, and 8 times 2 is 16. So when we find the greatest common factor when solving quadratics, we're going backwards. Essentially, we want to find the biggest factor of 8 and 16 that go into each other evenly. So we want to find a number that goes into both 8 and 16. And so what I'm going to do to introduce this is to write down the factors of each number. So let's start with 8. So the factors of 8 are 1, 2, 4, and 8. So those are all the numbers that go evenly into 8. So 1 divided by 8, or 8 divided by 1 is 8. 8 divided by 2 is 4. 8 divided by 4 is 2. And 8 divided by 8 equals 1. So those are all the numbers that divide 8 evenly. Let's do the same for 16. 1, 2, 4, 8, and 16. Again, all those numbers divide evenly into 16. So, now that I made these two different lists, which number is the greatest common factor? So looking at my list, it appears to be 8. If I look at it, 8 is the greatest common factor. So, here's what I do. If my greatest common factor is 8, essentially, remember when we distributed, we multiplied. When I take the greatest common factor, I'm going to divide both those terms by 8. And when we do that, rather than divide just by 8, we're going to write on the outside of our parentheses. And so that's how we get 8 divided by 8 is 1y, and 8 divided by 16 is 2. So 8 parentheses y plus 2. So again, finding the greatest common factor and pulling it out is the opposite of the distributive property. So that's the way you can kind of think about it. All right, so let's go on to our next slide. Okay. So 6x squared minus 15y. All right. So again, let's start by finding the factors of our coefficients. Let's start with 6. The factors of 6 are 1, 2, 3, and 6. The factors for 15 are 1, 3, 5, 15. Looking at our list, what is the biggest number both lists share? That is a 3. So that means we're going to divide 6 and 15 by 3, or factor out a 3 from both terms. We write that 3 on the outside of the parentheses, and then we do 6 divided by 3, which is 2, and we bring down the x squared. And then 15 divided by 3 is 5. That's as simple as that. That's how we find the greatest common factor and factor it out of, in this case, a binomial. All right, let's try one more binomial. Oh, wait, before we do that, look at this. Just to check your work, you can redistribute the 3 to see if it works. So if I redistribute this 3, 3 times 2 is 6, x squared. 3 times negative 5 is negative 15y. So if you do it correctly, you should get the same answer up at top. So let's do one more binomial together. And it's 3s to the 4th plus 16s. All right, so let's look at the numbers here. So let's find the factors of 3, 1, and 3. Factors of 16 are 1, 2, 4, and 8, and 16. Now in this case, do any of the numbers match? Or do any numbers on both my lists have a common factor? No, they don't. So there's not a number I can factor out, but the other thing you have to be looking for now are the variables. Okay? So S4 and S. Now, they both have an S in common. So how many S's can I pull out of both without taking too many? I have 4 available on 3s to the 4th, and I have 1 available on 16s. So that means I have 1 available for both. And that's the maximum I can take. So I'm going to pull out an S, because I can't pull out any of the numbers. Well, I could pull out a 1, but that won't help us. But I need to pull out 1s from both. So I'm still going to have 3s to the 3rd, because I pulled 1 out. And when I pull out the only s from 16, I'm just left with plus 16. All right, and let's take a look at our last example. Not only does this work with binomials, but we can do it with trinomials. Okay, so when we work with trinomials, what we do is, again, we circle all of our coefficients that need factors. Negative 2 has 1 and 2. 14 has 1, 2, 7, and 14. And 6 has 1, 2, 3, and 6. Looking at all of my lists, 2 seems to be the common factor. So I'm going to factor out a 2, but look at my variables. I have g to the 4th, g to the 2nd, and g. And I have 4 available, 2 available, 1 available. That means I can pull out 1 g from each. So I'm only going to pull a 2, but I'm also going to pull out a g. So when I do that, I'm going to get negative 1 g to the 3rd, because 2 divided by 2 is 1, and I pull out a g. 14 divided by 2 is 7, and I pull out a g, so it's g to the 1st, but we don't have to write the invisible one exponent. And then 6 divided by 2 is 3, and since I pulled out the only g, all I have left is that 3. So that is how you find the greatest common factor. If you need to rewind to watch any part of this video again, go ahead and do that. Make sure you take the quiz right under this video.